Consider a forced single degree of freedom system governed by x double dot of t plus 2 zeta omega n x dot of t plus omega n square x of t is equal to omega n square cos of omega t, where zeta and omega n are the damping ratio and undamped natural frequency of the system respectively, while omega is the forcing frequency. The amplitude of the forced steady state response of this system is given by 1 minus r square whole square plus 2 zeta r whole square whole power minus 1 by 2, where r is equal to omega by omega n. The peak amplitude of this response occurs at a frequency omega is equal to omega p. If omega d denotes the damped natural frequency of this system, which one of the following options is true? Let's look at the solution. We are given that the amplitude of forced steady state response of the system is A is equal to 1 by under root 1 minus r square whole square plus 2 zeta r whole square. Then in the denominator, the term inside the square root is considered as f of r. That means f of r is 1 minus r square whole square plus 2 zeta r whole square. Now, let us differentiate this function with respect to r. We get minus 2 plus 2r square plus 4 zeta square into 2r. For the amplitude to be maximum, df of r by dr should be equal to 0. Upon doing that and simplifying, we get r is equal to under root 1 minus 2 zeta square. Given that r is equal to omega by omega n and the peak amplitude occurs when omega is equal to omega p, then r becomes omega p by omega n, and we found out that r is equal to under root 1 minus 2 zeta square. From this, we get omega p is equal to under root 1 minus 2 zeta square into omega n. From the basics of forced vibrations, we know that damped natural frequency is written as under root 1 minus zeta square into omega n. Under root 1 minus 2 zeta square into omega n, and this is less than under root 1 minus zeta square into omega n, and this is less than omega n. But under root 1 minus 2 zeta square into omega n is nothing but omega p, which is less than under root 1 minus zeta square into omega n is nothing but omega d, which is in turn less than omega n. Hence, the correct answer to this question is option A.